The reason I got involved in Bloodhound is because it's an iconic, visionary program that opens people's eyes and starts conversations about what engineering is about, what science is about, technology and mathematics, and where that can lead. And it opens young people's eyes to the future and what they could end up doing. The Bloodhound education programme engages with over 5,000 schools and growing, and over 500 ambassadors, again growing. We provide a range of educational resources that teachers can use to add value and excitement to their lessons. These run from Key Stage 1 to Key Stage 5, and we even have a Bloodhound at University programme that's developing materials for use in undergraduate degrees. A good example of how we work was our recent event in Enfield, where we worked with 2 colleges along with the schools in their local area, primary and secondary schools, to put on a range of presentations and workshops focusing on computer science. We're pleased to have worked on in this project with our major sponsor, Metaswitch, who are an international technology company based in Enfield. They recruit from amongst the best graduates in the UK, and they're increasingly finding a problem with finding people with the right skills and the right qualifications to work for them. So they have a vested interest in promoting the potential of careers in their sector. The event's been a great success for everybody involved, and we've had some fantastic feedback from the schools, the colleges, and our partners in delivering the workshops. The children have had a fantastic time, and effectively they've been learning through having fun, and that's really key to the whole thing.
Hi, my name is Rhys. I'm from the Royal Academy of Engineering, and today we are showing the children Robbie the robot. Now, this is a new robot that the Royal Academy of Engineering is working on with John Panter, who's helped specially design it for us. And this is to try and encourage children to think about programming and the wider aspects of computing through robots and controlling physical objects. So what we're getting the children to do today is control the robot using these forward and reverse and left and right buttons today. And we're getting them to have races and do all sorts of fun things with the robots, getting them to bump into each other and things like that.
Okay, well, Promethean's one of the sponsors of the education side of Bloodhound. Promethean are probably most well known for interactive whiteboards, like the ones installed in this school here. We also make kind of handheld devices, but we're also interested in the whole professional development for teachers. So what we've been doing in the workshops today here is teaching kids some of the basic computer principles that are in operation in the Bloodhound car. We focused with the children on the winglets at the front, which respond in real time to changes on the wheel, so really to detect if the car's lifting up off the ground or not. And from there, the children were then able to make their own game. And so this is a simple way of constructing the program. It begins to execute when the green flag is pressed. You just put the blocks together, so this is a forever if loop. It's going to check whatever's inside here, so we can put something inside here. In this case, we're going to check that the up arrow is being pressed. If it is, the vehicle's going to move one step. And that's really how simple it is to create an initial program. And really, in literally less than a minute, a child can get that feeling of success and having control over the computer environment. Very, very powerful tool. Some people have discovered that you can record your voices. Who's made it move? Who've made your character move? Good. Who's made it say something with the looks? Good. And then the kids were really keen to go and see where they could go from that. What if I made it faster? What if I made it slower? How do I, so that really problem solving and critical thinking. You know, it's ideal now with the new computer science GCSE to get, you know, students in these primary ages, you know, really actively involved, and tools like this on the whiteboard make it really easy because there's not much typing involved. You literally drag the blocks around and build it like Lego. So, you know, a really powerful way of getting kids engaged with programming, you know, while thinking about things like control systems and feedback loops and sensing, which are all relevant to the Bloodhound car.
so my name's Lance Howarth. I work at Arm. Arm is the UK's leading technology company. It's probably the largest public technology company, and it's quite an amazing UK success story that, but not many people have heard of us. We have about sort of 2,300 employees, of which 1,600 are engineers, and so for us, actually getting good engineering graduates coming through in terms of computer science and microelectronics is hugely important for our business. The challenge that we face really is that technology has become so easy to use. In some ways, it's very accessible, but actually it's harder and harder in some ways for kids to get to understand what's going on underneath the sort of the keyboard and behind the screen. So doing things like the Bloodhound project, it's great iconic sort of symbol. You can really show what engineering is about and actually teach kids in a very short period of time different aspects of engineering and science and technology, and hopefully that it will inspire them to and their teachers to take this back to the classroom and carry that on.